This is the lecture for Chapter 7, Lesson 3, Sampling Distributions of Sample Means. What I'd like you to focus on for this lesson is how is the sampling distribution of a sample mean similar to the sampling distribution of a sample proportion, specifically with regard to center and spread as the sample size increases. So with center and then separately with spread as the sample size increases. So in order to first address that question, let's get some symbols straight to make sure you have them straight in your mind. X bar is the sample mean. So that refers to a number that's not a proportion, used to estimate our parameter for some variable. P hat, which is what we've talked about, is the sample proportion. So if we're talking about a proportion, like when we looked at the Reese's Pieces, what proportion of the candies were orange, then we're using P hat. If we were just looking at numbers, so the number of orange candies, for example, that were orange, and not a proportion, then we would use X bar. So remember, X bar is a sample mean, P hat is a proportion. So this is a proportion for one sample, X bar is a average for one sample. It's the mean of a sample. So keep in mind before what a sampling distribution is. It describes how the statistic varies in all possible samples of the same size from the population. Now this is important to understand that when we take 100 samples of pennies and look to see which ones were from the 2000s, 100 samples is not all possible samples of size 5 or size 10 like we did in class. So that's not the sampling distribution. What we're doing there is we're approximating the sampling distribution, because in reality for us to create all possible samples of the same size would be very tedious and take forever. So we just try to approximate it in order to see the pattern that's occurring with it. So a true sampling distribution would be all possible samples of the same size from the population. That's something that will pop up on quizzes and tests, and as well as the AP test. So if you have something that you've simulated, you want to call it an approximate sampling distribution. So unbiased estimator, remember X bar is going to be unbiased if the mean of the sampling distribution is equal to mu. This little symbol down here is mu. Mu represents the actual mean in the population. So that's like what we're trying to find out. So an unbiased estimator is our goal when we're collecting data and figuring out a way to interpret our data in order to figure out what the actual mean is, whether it's the mean number of people in America who had heart attacks last year or whatever it may be. An unbiased estimator would give us an accurate mean, the mean that's actually from the population. So X bar is our statistic, it's our mean from our sample. If it's an unbiased estimator, it gives us a value equal to mu, the actual mean of the parameter. So let's look at formulas that we can use with X bar, very similar to with P hat with our proportions. So standard deviation of X bar is given by the standard deviation of the population over the square root of n. So again, as sample size increases, the standard deviation of the sample goes down. So averages vary less than individual observations too. We can use it if the 10% condition applies, meaning that we've sampled less than 10% of the entire population. Quick tip too, if any of this is looking fuzzy on your screen, go down to the little thing that looks like a cog or a wheel and just click on it to improve the resolution. A little screen should pop up for YouTube to improve the resolution. So anyway, back to sample means. When we use a normal distribution, we can, to calculate approximate probabilities, so our sampling distribution will be normal if our population distribution is normal. The other time it will be normal is if we have a sample size of n equal to 30 or greater. In most cases it will be approximately normal. What we find is that as it increases, the sampling distribution becomes more and more normal in shape. So the same sampling the same thing we're investigating with a sample size of 30 wouldn't be as normal in shape as the sample size of 50, which wouldn't be as normal in shape as the sample size of 100. So larger sample size leads to a normal sampling distribution. The other time that it's normal is just what we have said before, which was the as long as the population distribution is normal. So even if we have a sample size of 5 or 10, then we would expect our sampling distribution of the sample mean to be normal. So larger sample size, preferable to have a normal distribution. So in a lot of ways, this is similar to sample proportions. The symbols are the most confusing, so keep in mind that p hat is a proportion, the sample proportion. X bar is the sample mean. So if we're talking about proportions, a number between 0 and 1 or a percent, then we're looking at p hat, proportions, and p representing the true proportion of the parameter. Remember, parameter population. So the true proportion in reality if we included all values. If we're looking at X bar, then we're looking at a mean, not a proportion. So those things are very key here. Other things that are key are knowing the 10% condition, that we can't sample more than 10% of the population. And the central limit theory is important too, that the larger sample sizes are preferable. We'll get, as the sample size increases, it becomes more normal. So we use n equals 30 as kind of the limit. So as soon as n is greater than or equal to 30, then we can say it's approximately normal that our sampling distribution is in most cases. And for our purposes, approximately normal. In class, we'll be looking at sampling distributions of X bar for non-normal populations to see how this works in a little activity. What I'd like you to do now is go ahead and read through Chapter 7, Lesson 3 in your book. It's on pages 442 through pages 453. Look over those examples too, and there's nice visuals in there that help in addition to this. And think about the activities that we have done so far. So here's your multiple choice question. We know that a sampling distribution of a sample mean, remember that's X bar, is approximately normal or possibly exactly normal when A, our sample size n is at least 30 in most cases according to the central limit theorem. B, the population distribution is normally or approximately normally distributed provided that the 10% condition is met, so that we're sampling less than 10% of the population. C, the 10% condition is met, we're sampling less than 10% of the population regardless of the population distribution. Or is it A and B or E, A and C? So take a look over those, look through the lesson in your book, go back over the summary especially on pages 453 to 454 and the examples given in the lesson in order to answer this multiple choice, and then the conceptual question that we talked about at the beginning of the lesson, which is how is the sampling distribution of a sample mean similar to the sampling distribution of a sample proportion? And what I really want you to address is just these aspects of center, and then the spread as the sample size n increases. So that's the conceptual question. I'm going to scroll back down to the multiple choice so you have it again.